We're going to talk about the Groovy programming language. The original version of this talk, when I gave it at the start of the year with the local JDBC music group, was just called Introduction to Groovy, but I decided to rename it to Groovy Baby to kind of give it a bit more Hollywood appeal, essentially, for the conference. But it's based on that talk. I've just jazzed it up a little bit. Groovy Baby inspiration is from Austin Powers. So, in that vein, let's just have a quick talk about what you can actually expect from the talk. Basically, it's going to be a quick Groovy 101. You know, what's Groovy? How is it similar to Java? How is it different to Java? What are the things that you probably need to know to understand some of the examples that I'm going to pull up later on? So the second half of the presentation is really around demonstrations of what I found useful in the Groovy programming language when I was using it on a particular project, which I'll explain in just a second. There was no, it's going to be no mention of the other Groovy projects, things like Grails or Gradle or Griffin or anything like that. We're not going to cover this. It's purely about the language itself and how it compares to Java in some respects, and having kind of a use case, or a case study rather, of how I actually applied it to solve some of the problems that I was facing. So if that's not what you're expecting, feel free to go to one of the sessions. You know, I won't be offended if you want to hop out, that's all fine. There is quite a bit of content to get through. I'm happy to take questions as we go, but I will keep an eye on the time, and I'll try and get some time in at the end to ask questions as well. I guess the other question really is, how groovy am I really? So let's set some context for that. I'm going to make it clear that I'm not really a Groovy expert. I'm an enthusiastic amateur, that's the best way of putting it. I have about 12 months of real hands-on, you know, in the trenches experience with Groovy, and that's what this is based on. As I said before, is the experience of building an automated test framework for actually a PeopleSoft, Oracle PeopleSoft implementation that we had no access to the underlying. So this was being provided software as a service, so we couldn't access the database or the underlying code or anything in there, so it was a complete black box to us. So there were a number of interesting problems we had to overcome, and I ended up building a custom system to actually test it. So the experience is based on the building of that system. Groovy is currently my go-to JVM language over Java. I am known to moonlight with Scala and Clojure, and I flick here and there with various languages at various times, but if I actually want to get some real work done, then Groovy is the one I go to first. It takes an awful lot these days to persuade me to actually write Java code, if I don't have to. So I guess the first question we really need to talk about is, what is Groovy? It's Groovy by name, Groovy by nature, as I like to say. It's a dynamically typed, pure object-oriented language that runs on the JVM. It looks like Java. It kind of feels a bit like Java. It compiles to Java bytecode, so you get class files out the end of it when you compile it. It plays really nicely with Java and all of the Java ecosystem, so pretty much anywhere you can use Java, you can use Groovy. Anything you've written in Java, you can use from Groovy. But it is much less tedious than Java. It sucks, basically. So, that said, there are a number of similarities, right? So, Java and Groovy share the same packaging system, so the same namespacing mechanisms are implied. The class and method definitions, statements, expressions, control structures, operators, assignment, exception handling, literals, the way that you instantiate objects and dereference them and do method calling, they're all basically the same. They all look the same, they all feel the same. There's not that much to be sort of feel alien, if you like. But there are a significant number of differences as well, and we'll see some of them as we go through some of the examples. Groovy doesn't force you to put in semicolons at the end of every line. The only time you need to put a semicolon in is if you put in two statements on one line, you put a semicolon between them to separate them. But if you put in two statements on one line, you're probably in pretty bad form anyway. You want to split them up. It also allows you to drop the parentheses, so around method arguments and things like that, so you can clean up some of the syntax that way. Sometimes it will allow you to do that, not always. It will allow you to drop the dot operator sometimes, and we'll see some examples of these later. The other thing that it does is actually really helpful, you don't realise it at first, is that it imports a whole bunch of packages for you. So Ordinarily, when you're writing Java code, you get everything in the java.lang package available straight there, so you can do runtime or you get objects and class and all those sorts of things. But you don't, and the basic data types. But you don't get a lot of the classes. You actually need to do some real work, like java.util, so you can get access to your list collections. Java.net, if you want to do any network I/O, or if you want to do any I/O, you've got to get the I/O package, right? So Groovy goes and pulls all of those things in for you. It gives you the java.lang. It also gives you .util, .math, .io. For reasons we'll see in a minute, it also pulls in java.math.biginteger, so you can do arbitrarily large integers, and big decimal, so you can do arbitrary precision floating points. On top of that, it also pulls into Groovy-specific packages, Groovy.lang and Groovy.util, and they're basically extensions to the Java equivalent. So you get all the nice Java stuff, lists and what have you, with a bit of Groovy magic sprinkled over the top. And again, we'll see that as we go through. So hopefully by this point, you're asking the question, how do I start being more groovy? Yeah, I'm clearly not groovy, but you know, the programming language is. Obviously, you can just download and install it, and that's a great way to get going. It's got really good IDE support in Eclipse and in IntelliJ IDE. NetBeans does have support for it, but it's a little bit behind the times now. It's behind the two. You can use straightforward command line editor and the command line the old-fashioned way, which is a great way to learn new languages as well. But there are a few other ways that make it easy to basically experiment with the language. So, in common with a lot of dynamic programming languages, we have a REPL or a read, evaluate, print loop called Groovy shell, and that allows you to just type commands in, and you get immediate feedback, and you can build up a small program as you go. So if you just want to play around with the language, it's a really good way of doing that. There is also the Groovy console, which is a slightly more sophisticated, not really a REPL environment, but it gives you a little editor. You can type code in, you can type little scripts in, you can run them, you can load scripts, you can save them. There's all kinds of things you can do with the output, the way it looks, and things like that. But this is another really good way of just being able to pack a little bit of code together, try it out, see if it works. And this is what I tend to go to if I want to do experiments, more so than the Groovy shell. The other thing that we have is Groovy Web Console. So the Groovy Web Console is actually it's actually built on something called Galaxian, which is a lightweight web application framework that runs on Google App Engine. And it gives you an interactive console on the web, in a web browser. So you can go and you can type code into this thing and it will evaluate the scripts for you. Something like this. This works. And we go on that. All being well, web connection up. Woohoo! We get the little hello OSDC down there. So you can actually do everything, or nearly everything you can do in the Groovy console, you can actually do on here, and you don't actually need to install anything. So if you just want to play around with it. So that's kind of the ways that you can experiment with it. We're actually going to play with the Groovy console most of today, because that's the easiest way for me to show you and demonstrate what it is that I want to see. So let's go and do that. Let's see some actual code. So the rest of this conversation, is going to be done here. And let's hope that it managed to keep it all together. So I'm going to get through everything in time. So as I said, Groovy is a pure object-oriented language. That means there are no primitives. So we don't have an int lowercase I primitive. Oops. If we actually execute that, it returns and tells us that it's an integer class. It's not an int. There's no such thing as an int in Groovy. Same with all the primitives. So if we change that to a floating point, then we get a big decimal. Not an uppercase F float or uppercase D double. We actually get a big decimal. And that basically means you've got arbitrary precision floating points by default. So there are certain things that Groovy can do in terms of calculations that will be accurate that you don't get in a lot of other dynamic languages because it does this by default for you. Which is handy if you need really accurate numbers, which I haven't found the use for as yet, but you never know when. Boolean's the same. It's a big B Boolean, not a little b Boolean like you have in Java. So it's the class. One of the possible gotchas, and I'll try and point these out as we go along, is that this would normally be a lowercase c char in Java. It's actually a string in Groovy. So there is a subtle difference between single quotes and double quotes, and I'll come back to that shortly. But just be warned, if you're trying to do something with a char, you won't get one. It doesn't exist. You're always going to be a string. And the other thing that Groovy is quite helpful with is it will automatically marshal results for you. So if you're adding two things that are actually different, it will give you the most accurate results. So this gives you a big decimal back because one of the other parameters is a big decimal. It will give you back an int, even though the result can be represented as an integer. So that's sort of the basics of the primitive, or would-be primitive types. There are none. They're all objects. The Groovy community does have a bit of a sense of humour. So we come back and talk about strings, and they call strings Groovy strings or G strings for short. So it's one of the few places where you can get away with saying that in the office, I guess. They kind of look like Java strings, but they've got a few extra special powers that you can do with them. So if we look in the basic one, we can say OSDC is declare a variable, called name, we assign the value OSDC. One of the nice things about G strings is that you can actually do substitution in there. So if you just do $name, that'll substitute the value of the variable name into that position in the string. So evaluate that. Hello OSDC. Cool. You can also substitute in the results of expressions. So really, OSDC should be uppercase, right? So let's do that. We get uppercase as well. If you're going to do an expression, you do need to put those braces in. You can't do it just as name.to uppercase. That's the way that it passes. Here's another one of the gotchas, or this actually is useful in places, but it's something you need to be aware of. If you use single quotes instead of double quotes, that's actually a straightforward Java string, not a G string. So if we run that, it doesn't attempt to do the substitution in there. Okay. Now, that's an easy mistake to make, and if you suddenly see things like this popping out in your code, you should at least know why it's happening, as I've told you. But it's also quite useful if you're working with code. I found a couple of places where passing stuff from Groovy to Java, I needed to actually make it specifically a Java string instead of a G string for it to work properly. So it can be helpful in those circumstances as well. There is another type of quote that you can do, and this works with both single and double, but we're going to use double quotes. If you triple quote something, you end up with a multi-line string. And I can't type, which is not helpful when you're trying to write code. So if we do triple quotes, then we can actually split lines up across strings and not have to do horrible close string plus close string plus blah, blah, blah. Yep.
Leading space is significant on the second, third, fourth line for that?
Only in so much as it will come out in the string itself.
Yes,
so if I do that, then although they're both at the start of the line, they're going to get 3 white space characters at the start. So you can do pretty much what you want. You can use it as a format. But it's essentially like a pre-formatted block once you put the triple quotes in. So that's strings. One of the things we need to really cover with Groovy is it's like some politicians, I guess. Groovy's got its own concept of truth. Thankfully, Groovy's concept is at least consistent, which is good. It's better than most politicians. So let's get rid of this. Basically, there are a whole bunch of things that evaluate the true and false to make it a bit easier to write expressions down. So things like numerics, if you treat them as a Boolean, which you can do casting much more nicely, by the way, in Groovy, if you just used it as keyword rather than having to go Boolean or brackets Boolean. You're not doing that stuff. 0 is false in Groovy. Anything that's not 0, such as 1, will be true, or even -1 will be true. Same goes for floating points. If we put 0.0 in there, that's false. 0.1 is true. More interestingly, things like empty list, if you evaluate, and that's the shorthand for empty list, but we'll look at lists in a minute. Evaluate as false. same if you put something in the list, it evaluates as true. Same with maps. That's the shorthand for a map, and again we'll look at maps in a minute. That evaluates to false. Put something actually in the map, it evaluates to true. The other thing that's quite handy, I'll explain why in just 1 second, is the null evaluates to false. So rather, if you're in Java and you have to write, such a thing is empty or such a thing dot size greater than 0, you don't have to do that anymore. You just say, oh, well, just throw the collection class at it, right? And if it's null or it's empty, you're going to get false. You're not going to execute that code in that block, inside the thing block. So it actually makes it quite a bit easier to write that stuff. And, less typing, less code is usually a good thing. Less things to go wrong. So that's a lot of the basic stuff. I'm going to try and step up a little bit and talk about a couple of the more advanced features, and then we'll look at some of the ways that I've used those. So I'm going to talk about closures. Now, has anybody used closures before, either in Groovy or other programming language? So closures are, if you're uninitiated, they're basically blocks of code that you can pass around as data. So you can take a block of code and then you can pass it as an argument to another method, and that argument can then use that code on something else. In Groovy, that's often used as a replacement for anonymous inner classes. So if you've been a Java programmer, you'll have come across a situation where you add a listener. The listener interface has got one method in it, so you just kind of do new listener interface, blah, 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 give it the method and implement that, and you end up with this horrible yucky bit of code in the middle of wherever it is you're writing your code. You don't have to do that with Groovy. You can basically write that and pass that thing around as something that can be used. So you don't have to do a lot of that stuff. Closures themselves are actually promised for Java 8. They were originally promised for Java 7, and we didn't deliver them. It sounds that they're still probably arguing about it, but we'll see that it may come into Java eventually at some point. Maybe, who knows. So let's have a look. It's easier to see in an example, so I'll show you a couple. I'm going to load this up because it's I want to get through things in time. Okay, really simple example of a closure. First 3 lines, we've got a closure which we've called cool, or a variable we've called cool, and we've assigned the closure to, which is the curly braces, and all that the closure does is print closures are cool to the console, right? It's not doing anything particularly clever. Lines 5 to 7, just declare the method in this Groovy script, called do something that accepts a closure. Okay. Inside the method, we just call the closure. We're not doing anything particularly clever with it. We're just calling it and saying, all right, go and run whatever you're supposed to do. You do it now. And you just do that by putting the empty parentheses at the end, unless it's something with arguments, which we'll see in the next example. Then we can call the method do something and pass it the closure cool. So what we're actually doing is saying, well, look, here's a block of code, and I want you to go and run. And that block of code, when it runs, should go and print closures are cool to the command line. So clear that out, right? There we go. Closures are good. And you can pass any kind of code around like that. Basically, just put it all in the block and pass it around. It gets a bit more interesting when you start putting parameters on your closures, which uses this slightly different or slightly enhanced syntax. So in this case, we're actually saying, well, this closure can take an argument called adjective. Sorry, I just read that for a second. And it just prints, whatever you want to describe adjectives as. And then we can close that, and instead of using empty parentheses, we can just pass the parameters in, like we just called any other method in Java, right? In terms of how it looks when you call it, it doesn't look any different, which kind of makes sense. So you can actually parameterize closures as well, and if we call this one's just calling the closure directly with the parameter so cool that they're hot. Right, if we run it to get closure so cool that they're hot, which is cool. Does that make sense? Simply enough. Closures are kind of important to know when you're dealing with Groovy collections. There we go. So I'm going to look first of all at lists, and then we'll have a quick look at maps as well. So we did see the empty list, the shorthand for creating an empty list, which is just 2 square brackets, look like an empty array. Really simple. If we actually look at what that gives us, it's just a Java util array list, which means we can pass these things, we can create them with nice groovy syntax and pass them straight into Java code that would expect anything that implements a list interface, it will work. Naturally, this is groovy, and we sprinkle a bit of magic on these things. So they can do all kinds of other stuff as well, but we'll have a look at some of the nice bits of syntax. So if we want to declare something with something actually in it, we just put it in the middle. If we want to declare multiple things as being in the list, then we just declare them like that. Get those out. Note that these lists are heterogeneous, so you can actually mix types in there. You don't have to have a list that's just integers, or a list that's just strings, or a list that's just mega objects, such and such. You can mix and match whatever you want in there. It doesn't really care. It gives us some nice operators, so we can actually concatenate lists using the plus operator. So we get a list with 1A, 2B, which is all good. We can also just append things to lists using the left shift operator. So do things like that, which is another nice syntax. You don't have to do the .append blah stuff there. So that's pretty cool. We can also take things away from lists. So we do. So if we subtract the list with just A in it from the list with ABA, then we should, all being well, just get a list with B left in it. So you can actually remove things from lists using other lists as well. So there's all kinds of things you can do with these collections. We can do things like, all these operators have been overloaded, so you can double the list, you can duplicate it twice on yourself just by multiplying it by 2, or triple it by multiplying by 3, or whatever. So you can create lots of repeated things very easily. Just, if you want to do ABC 6 million times, and ABC times 6 million gets you there. There are, let's go to this, we actually give ourselves a list to play with. So a simple list. If you want to access something within the list, then you can use the array index syntax like that. You don't have to do the .get blah stuff, right? Again, shorter, simpler, less code, better. That gives us the second element in the list. It's still zero based as with Java. But you can also do ranges. So we can say, well, I want the element, the second to fourth element, effectively. It gives us 2, 3, and 4. You can comma separate them. So second, third, fourth, and sixth element. That's what you get out. You can quite cheekily index from the end of the list. So if we want the last element, we just do -1. If we want the third to last element, -3. And that works with ranges and in comma separated lists as well. So you've got lots of nice ways to be able to actually access a list. There's also a whole heap of interesting methods you can run. So we've got things that will be pretty obvious, like reverse. Just reverses the order of the list. But these things kind of get a bit more interesting when you start combining them with the closures that we were just looking at. So there's a find all method which accepts a closure, which means that we can do things like that. Now, the last parameter to a method is a closure. You don't need to put the brackets around it, so you can do things like this. So find all will accept that closure, that block of code, and use that, and basically evaluate it against each of the elements in the list. And anything that passes that condition, it's going to return a Boolean value, will be included in the resulting set. So what we're doing here, it is a special variable that says the thing in the list at the element of that particular position. If the modulus of that divided by 2 is 1, if the remainder is 1, then we've got an odd number essentially. So we should get all those numbers out if we run this, which we do, which is cool. But the result of that is just a list, which means that we can actually chain calls together. So collect is like a mapping function. It allows us to do some sort of transform. It's another one of the things that the Groovy GDK actually gives us from the enhancements to the list. So we can take each of those odd numbers, multiply them by 2, and make them all even again. So we don't want odd numbers, we just want even numbers. So there we go. And you can then do something else to that list and do all that kind of stuff. So that's kind of where you start to see some of the power of what the collections API and combined with closures can actually do. There are other really useful simple things like min will give us the minimum, max will give us the maximum. There you go. Sum will actually have the list of 36. We can do tests, again using closures. We can say, is there anything in the list that is less than 0? No. Cool. We can also do the inverse of that and check that everything in the list is actually greater than 0 just by doing everything. That's true. Cool. One of the other things that I have actually used, which is useful, is just to do a quick the join method, and you can just pass it whatever string you want. So you'll separate all the elements in the list with a vertical pipe. This will give you a string, separate it with all the elements of the list separated by a vertical pipe, and obviously you can do a comma or arrows or something a bit longer. And you can just build strings up that way. So if you've got a whole list of things, particularly if you've got a list of other strings and you want to join them together with something, you can do that. That's kind of nice. If you're coming from a functional programming background, there are a whole bunch of other things that it allows you to do on this as well, but it's the last actual example I'm going to try to type out. There's this thing called a jet, which is like a fold if you're using various other languages. This basically allows you to work through, and just to give you an idea of a slightly more complicated example. Which I'll explain in a second. I can't type and talk very well. Try and make sure I spell it correctly. Oops. So what this is actually going to do, we've got a closure that takes two parameters, an accumulator and a value. The 0 that we've got at the front will be the initial value of the accumulator. And then it's going to go through for every element in the list, and because we've got accumulator plus value in the body of the closure, it's going to add the value to whatever the current value of the accumulator is, and then call the thing again with the new value of the accumulator being passed in. So what this should effectively do is go through and sum all the values in the list. And we've got 36, I think, when this happened before. 36. Cool. So all that's just a bit of a long-handed way considering we've just got sum, but it does the same thing. And you can do really good reductions on data sets using this type of method. So it's kind of handy to know, but it just gives you a little bit more of an example of a more complicated example.
Do closures have access to the environment, variables in the environment?
Do closures have access to variables in the environment? They follow. You need if it was globally accessible, then yes, I think. But generally, you pass them whatever you want in as a parameter to it, or whatever you want to use in there.
So you can't have a local function, but x equals y, and x inside that closure to the function.
So we can try it. Well, this is going to be global, so it's kind of a bit. I think this will work.
Well, if you could redo that though, if you said accumulator equals 0, and then instead of inject, you do a collect just over a single argument value, and have.
Right. But I know it will work with local.
Yeah. So it's where it works for lexically scope variables.
We'll have to go at the end. Remind me, and we'll play with it, see what we can do. There are also methods for doing sorting, for removing duplicates, for counting occurrences of elements within the list, for flattening lists. If you've got a list that's made up of other lists, you can flatten it down into one great big list. You can find intersections of lists and loads of other cool things. So there's a huge amount of stuff that you can actually do with the Groovy collections, or the Groovy list collection, over what you can do with the standard Java util list collection. The kind of counterpart that we have with these are maps, which are also known as hashes or dictionaries if you're coming from various other languages. As you saw before, an empty map is declared like that. And let's do that. It's just a linked hash map. So again, you can pass this to things that just expect something implementing the Java util map interface. We give ourselves a little map to play with. So you can actually declare, find maps really easily. If I could type. There we go. So that gives us a map with, basically it's a whole bunch of key value pairs. So we've got key of A value mapped to the value of 1, key of B mapped to the value of 2, key of C mapped to the value of 3. Again, this is another gotcha moment. If we do that, it goes horribly wrong, even though that's exactly what we put in when we declared it. And the reason for that is the top line is a shorthand notation, and those keys get converted to strings in the actual map. So if you try and pull it back out just by giving it what you originally gave when you put it in, it doesn't actually work, which is a bit of a pain. So if it all goes horribly wrong, you need to just convert that to a string and then it will actually work correctly.
Can you use explicit strings for the keys in the declaration?
Yes, you can. You can basically use any object as the key, if you want, but if you're using that notation, it gets converted to strings, so that's the thing to basically watch out for.
Insert a key as a value of A and you need to use the notation.
You do, you need to enclose it with parentheses to do that. So I did have that example and I took it out. I thought it was a bit educational for most people, but there you go. So yes, you can do that. You can use the value of something as well. So that's going to be a bit more difficult to follow what's going on if you do that. In some cases that's caused confusion, but yes, it's certainly possible. Where are we up to? Yeah.
The order of the elements in the map retained or not?
Yes, because it's a linked hash map, I think. Okay. So it will retain order. You can override or you can change the value. Pull that back out. Just by assigning, like you do basically with you can use the array type syntax to go and override the value of A with 0. We can also add extra elements to the end in the same way, so we can add extra elements where it goes completely independent. But so if the key doesn't exist, it just creates it, throws the value in against it. That's all array notation. What you can do, which is a bit of a way around that first gotcha, is you can actually use dot notation to access things. If your keys are strings, then you can actually do dots in the string, as long as it's not got spaces in it, then you need to quote it. But if you've got strings with no spaces, then you can actually use that record of dot notation to get to the values of maps, which is pretty cool. And that's actually, I did use that in my stuff, you'll see that later on. You can also use the traditional get. And this gives you the default value syntax. This is basically another gotcha. So if we do that, we try to do a read, or we call something that looks like a getter, and it actually mutates our map for us, which is perhaps not what you actually intended. Generally speaking, getters don't mutate things. That one does. So be warned, or don't use that syntax basically. It's not as confusing if you use one of the other syntax options.
Sorry, Craig, can you just clarify? What's that get actually doing?
So that's looking for the value of A.
Or is it doing something
So I'll give you
unexpected?
Map.get. So if I call that again, with the value of 10, for argument's sake. So what it does is it says, go and give me the value of E, but if E doesn't exist, give me the value of 5. And what it actually does is put E and 5 into the map for you, so that when you call it the next time, you get 5 back. So in this case, where we're calling it twice, the default value doesn't get used, because the first time we called it, it mutated the map for us.
So it's get was it?
Yeah, it's kind of like get unless it's not there, in which case set it and then get it back, please. It's a bit of a naughty one. So it's one of those classic API
now we realise what a disaster it is. At the time, it seemed like a good idea.
Yeah, it's kind of like, oops. So that, try not to use that syntax is basically my argument, because it's going to trip you up. Like I know it would trip me up if I used it. So I normally use the dot record syntax to count key strings. That's the thing that I tend to use. So that's basically what that's doing. What else have we got? So again, there are loads of methods that take closures, so we can actually, no, not Kelly, how about value? That's even better. So we can actually do something that iterates over everything in the map, takes each key value pair and does something with them. So we'll just do something pretty simple, just print them out so we can say P equals dollar key value. God, typing's terrible today. Great. Oh, it's the building code. There we go. That's a bit better. So we can go through and quickly print things out or do whatever you want to do with them. But there's a whole bunch of methods like there are on the list that will actually accept a closure, which allow you to do things with the elements that are in the map. So that's all pretty good stuff. Now that is probably enough to get you, if you're not seeing Groovy before, it should be enough to get you through the examples that I'm going to go through and show you the ways that I've actually used Groovy and how I found it to be beneficial to the work that I was doing on this test automation framework. One of the first things, and this is pretty testing specific, but it's a nice simple example to start with, is something called power assertions. So you've probably seen the assert keyword in Java, and you can make some assertion about your code that some property is being upheld at that particular point in the execution. And that's all good and well, but Java doesn't really give you a whole bunch of information back. Power assertions, on the other hand, have absolutely fantastic output. So in this case, it's really simple. We've got a variable called x with value 1, a variable called y with value 2. If you try and assert those two things are equal, and still we've proven, or not disproven, that 1 is equal to 2. So hopefully this will go bang, and we get some output. And there we go. All I've got down here is a really nicely formatted telling us how our assertion blew up. It's saying, okay, well, your equals operation became false. And it became false because the operands that are sat on the other side have the value 1 and 2. And those two things aren't equal, or at least plus can't be checked. So it gives you something really nice. And it actually scales up pretty well. So this is just taking it up one level further. But we have that. Again, x and y equal to 1 and 2. We define a simple little function that says whether something is odd, just pass a value in, check to see whether the remainder is 1. Obviously you can do this in menu anyway, but that's all it's doing. And then we try and assert that they're both odd, which they shouldn't be if it's one's even, right? Ooh, off it goes again. And it still breaks it down nicely. So we know that the whole thing was false. We know that the left-hand side was true, that the value of x at that point was 1, and the right-hand side was false, and the value of 1 was 2. As I said, I was building a testing framework, and there were plenty of bugs in the test framework itself that we had to figure out, right? And we're trying to do stuff and work out what's going on. These assertions saved us a whole heap of time trying to do investigations, because when it blew up, we could look at the output and go, why is that value in there? And go back and figure it out, right? So it gives you, you didn't need to go and work what you do. You get a stack trace as well. It's all down here. Whee! All that horrible stuff. But you don't really need to do that. You kind of go, well, I know where that assertion is. You can go straight to that line of code, figure out why it's got the wrong value or why you're doing something stupid with it, which is usually the case, and go and fix it. And it does have got quite big expressions that are obviously a bit more complicated than that one, where it still breaks everything down. You can see all the values really easily, so it's a really good way of actually putting debug stuff.
I'm challenged by that statement. Could you just walk through that example and tell me how you do it?
So each of these lines is pointing to the actual part of the expression and what its value is. So if we take the whole AND expression from start to finish, its value is false. Because this has got two operands, one on this side, one on that side. The logical AND says that both of these have got to be true in order for the result to be true. If one of them is not true, we can see that here. This side is false, that side is true. So the whole result has to be false. We can then look into that on each operand and say, well, if we just take that part of it, this whole thing, odd y, is false. And the value y was 2. And on this side, the whole thing, odd x, was true, and the value of x was 1. So it's always pointing to the part of the expression to give you what the value was at the point the assertion was from. Correct, makes sense?
Just out of interest, can you make use of that value?
Yeah. So it's, because this is lazily evaluated, it knows the left-hand side was false, and never actually calculated the right-hand side. That's a Java. It's a
Right, yeah.
So I didn't have to calculate the right-hand side because the left operand was already false. Was that what you were looking for?
No, it actually, how it's going to handle something that's going to otherwise.
They do 1 and 2000.
Yes, it does a pretty good job of laying stuff out. Like I say, I've seen some pretty complicated ones.
Well,
and you
let's
can
do
sort of-
1001 because then that's going to make it much more interesting.
that way.
Yeah, that'll be fine.
So it usually manages to figure it out reasonably well. The fairies do a good job of working it out. I don't know. Somebody wrote it pretty good. This actually came out of, it's just ported into the core of Groovy from a testing framework called Spot. So it's written by a guy called Peter Niederweiser, who's quite often speaks at conferences and works for GroovyWS now, I think. But yeah, they liked it so much they stole it and put it in the core language. So it's one of the things I really like about it.
Going to be
Back, steal and borrow. Well, Groovy can't really complain too much because if you look closely at Groovy and you've got any Ruby experience, that's all I'm going to say.
Yeah.
So that's power. Is that okay? Any big questions on that? Yeah, cool. Right, let's go. See what else we can get in. Okay, let's have a look. Mixins. So, does anybody know what a mixin is? Happen you. So, that didn't work. Where did that go? That's it. Get rid of that. There we go. That's a bit better. Okay, mixins basically allow you to add functionalities to a class without actually needing any access to the original source code. So after the event, after the class has been created, we can take some other functionality, and it's one of the ways we can take some other functionality and basically graft it into another class. There are basically 3 different ways of doing this well, 4 different ways maybe, but we're going to look at 3 specifically. Ways of doing this in Groovy. The first is this. So in this particular case, and this is pretty much exactly what I wanted to do for the test framework. The test framework was running on Jenkins, and we just wanted to log all the steps. It was testing a web application essentially. I wanted to log all of the steps out as it was going through, so that if the thing went wrong, somebody could manually pick up the log and say, okay, I need to type this into this field, select this value in this drop-down box, click on this button, and just get a really basic set of steps that they could follow and reproduce the problem manually. So I wanted to put some basic logging functionality in across a whole bunch of things. I didn't want to use a logging framework to do it because I just wanted to dump it to the standard output. So this is, like I said, this is one of the ways. Not the way that I ended up using. We'll see that in a minute. But what I did was create a logger class with a log method in it, and all it's doing is taking a string and dumping it to standard out, prefixed with this chevron, right arrow and a space. And then we've got another class, which will be our class that we want to actually take this functionality, and these can be split into 2 separate class files. They're just in the same thing for the purpose of the demonstration. And we use a static initializer, which you don't see that often in a lot of Java code either, but basically what that does is the first time the class gets hit, so you don't even have to instantiate anything, you just need to reference that class, it'll run that code. And what that code does is it mixes in the logger class into the foo class. So now foo has picked up the method log from the logger class. So when we come down here and we instantiate a new foo, we can go and call log, even though, as you can plainly see, there's no log method, no methods at all in here, right? We've just got a static initializer. So when we run it, hey presto, there goes our log method. The problem with this is that we need to make sure that we reference the class foo, or we reference that class to actually get the mixin put in there, which it works, that's all good, but I didn't really like that. There is a slight variation on this. This one. It's a bit shorter, and this is a bit more runtime. Same logger class at the top, exactly the same. We declare a list already, so we've now got a list that's already been created. But then we can just call on the list class, or the list interface essentially, mixin logger. So now I'm actually mixing the logger class in to the list class, but we've already created the mylist up there. It doesn't matter, because we've changed the actual class definition and added the log method into it. So this still works, even though I created the list before I actually mixed the logger functionality in. I can still call log, and it's still logged out. So I can actually have lots of choices about how I graph this functionality, and this one's very much a runtime thing, and this one you really do need to have some way of triggering this code, which is why I didn't use it. The one that I actually used, which I think is a lot clearer as what's going on, and also it does this at compile time instead of runtime, is something called delegates. So again, exactly the same logger class. So we've got a bar class instead of a food class. But inside there, we've just declared a property, or field, called logger, and we've instantiated it. And logger is of type logger, big L logger, the class at the top. And we just annotated it with delegates. That annotation triggers something called an abstract syntax transformation, I think, an AST transform, an abstract syntax tree transformation. And what that basically does is, as the code's compiling, it says, oh, actually, you want this to be inside that class. Again, it does what the mixing does at runtime, which says, oh, go and do that at compile time. And this has two key advantages for me. One is, if you're using an IDE, you can actually work this out and know that that is in there, so you don't get squiggly lines saying, I don't know what the log method is, so you don't accidentally confuse it with something that's broken, which happens if you do it the other two ways. It also means that it's pretty obvious, like you can't not hit this code, right? It's actually a method, it's actually something that's declared within that class, and it's really simple. It's not, you don't have to use magic static initializers or anything like that. You just use an annotation, which most people these days are used to. So it's a lot clearer what the intent of the code is. And it works the same way, right? We call bar's got no log method, but we can call a log and we can pass in delegation for the nation, and woohoo, we get our log out. Go.
Can you reopen a class if you do have the code yourself for any purpose, or is this the only thing I can do inside the pair of curly brackets there?
No, you can do whatever else. You can. That class is no different to any other class. It's just that's one thing, and you can mix multiple delegates in if you want multiple mix-ins.
What if the bar class has a log method?
Then you've got problems.
Is it a compile error or a runtime error, or will it just run the bar class?
I think it'll compile. I think it fast out compile time.
And what if there's multiple delegates for the same method?
Then you're also in trouble. So we do that log. So I think we're going to go bang. Let's see. Hey, bang. So it doesn't actually compile. It uses that one in preference. So it doesn't blow up, which is
What if there's two
the
delegates?
joys of using a dynamically typed language.
What if two delegates have the same method?
That's something we can try at the end if you want. I think you probably get you will get one of them. Both of them. Yeah, pretty much. If that does that, I expect the other one. If you have two delegates, you'll get the functionality of one, not the other. You'll just lose it in the next place.
Yeah, but so this example is different from the previous one in that you create a new class here, but that now has the logger in it. In this example, you added them to the logger class.
No. They're all, so the example's the same. So I had the class name foo. I changed it to bar in this example. I don't know why I did that, but that could be renamed foo. In every case, we're actually adding the functionality of logger to whatever the other class is. So if that was foo, it would be foo.
Right, it's like inheritance.
It's more like aspect-oriented programming, I guess. I've done anything around that.
What a mixin is, it's a component. It's a pluggable component that you can add into the declaration of an existing class to give that class extra features.
Are you a Java programmer, predominantly? Yes, sorry.
Yeah.
Oh, so okay. I'm going to say that for Java programmers, they're a bit like interfaces with functionality. So you can add multiple interfaces in, but these things you can actually have functionality attached to them. That's not quite the right way to think about it, but it might help in some cases.
Craig, when is the new logger called?
When the class is instantiated, or when the object is instantiated from the class more correctly. Okay. The other thing, which is kind of similar to this that we used, was some metaprogramming, which anybody from a dynamic languages background will probably already know. So this gives you another way to extend classes at runtime. Again, it doesn't require access to the original source. The actual problem I was trying to solve here was that we were scraping a whole bunch of data from this system, and we just needed to be able to get thousands of entries back, and we just needed to pick a subset of them. We needed to pick 1 or 5 or 10, run our tests against those particular pieces of data. But we wanted to select that data at random. So if you're doing this in Java, what you end up with is something that looks like this, right? So we've got a list which has just got numbers 1 to 5 in it, and you end up with this sort of this helper class, right? And you end up with a static. It's got no data associated with it. It's just got this utility method, pick one from, and you give it a list, and it goes and works out a random index to the list and pulls that out and returns it back. Right? And then you end up choose a pick one from my list, which is not bad, but it's kind of it's a bit wrong because you really, this functionality behavior belongs with the list, not in some other class that's just hanging around and doing utility stuff, right? So that works absolutely fine and gives us, reasonably random-ish results. But it's not really what I wanted. So this was also a bit of an excuse just to play with Groovy's method programming, but you can do it this way instead and actually graft that functionality back in to the list class. Again, the same list that we declared at the top. Now what we're doing is we're saying, well, let's go grab the meta class, which is how Groovy does a lot of its magic, and add a new method to it. Essentially, we give it the closure and say, right, okay, go run this code whenever anybody calls pick1 on the list class. The delegate is like another one of the special variables. It's a bit like it that we saw earlier, and it refers to the instance of list on which pick1 is called, right? So basically, when we call myList.pick1, if you substitute myList into where it says delegate, that's effectively what it's doing for any list that you care to call pick1 on. Otherwise, that code's identical to the code we had before. It's doing exactly the same thing. But now we don't have to have that chooser pick1 from cruft hanging around. We just say, well, it's a list, I want to pick one from it, so I'm going to call pick1 on list. And it does exactly the same thing, right? Let's play that. Except it's always returning 3. Good. I say, oh my god, there we go, so that some sort of random-ish numbers coming through. So that kind of helps clean up API and get rid of classes that you don't actually need hanging around. They're only hanging around because you're trying to work around other issues within Java itself, essentially. So that's pretty cool. Does that make sense to everybody? Right, okay. 2 things to go, and 9 minutes to do it. It's all good. This is the biggest example that I've got. Yeah, that one. Groovy has a really nice SQL API, right? And if you've used JDBC, you'll know that it's, if you use the .NET equivalent, that's even worse, unbelievably. But JDBC is not particularly great either. Groovy SQL basically tries to clean all that up and it presents a much nicer API. And it gives you, as you'll see, a lot of stuff that actually gets you somewhere towards looking like an ORM or an object relational mapping system like Hibernate, but it doesn't do any of that stuff. It's just the mechanisms that it uses and the API that it pulls back allow you to pull a few tricks which make it look pretty, essentially. So here we've got to import the SQL class, because that's not one of the ones that's pulled in by default. On the SQL class, we call new instance, and we just pass it the JDBC initialization string. So you can use, I'm using an in-memory HSQLDB database just for the purpose of the demonstration, but you can make that Oracle or MySQL or Postgres or whatever you want. That's all fine. All those work. The next bit, lines 5 to 11, actually allows us to go and execute a SQL statement. And here we're seeing a couple of things coming together that we talked about earlier, right? First of all, we've dropped the parentheses. So that's actually, there are parentheses effectively there and there. But we don't need them, we've got them, just noise. We've also used a multi-line string, triple quotes, which means that we can then format this into something that's actually legible, as opposed to being one cryptic one-line text. So all that's doing is creating a simple table called person. It's got 3 columns, one called first name, one called last name, they've got varchar, and then an integer for the age. That's it. So that's cool. So that goes, that'll create our database, and that executes that SQL statement against the database. You don't need anything else. You don't need to worry about any of the other crap you have to do with JDBC. That just does it for you. This next little block, it's just, I need some data in the database just to prove the demonstration, right? This is a list of lists, and we iterate over the outer list. So each element is itself a list, using the each method, and that, as we've seen before, takes a closure. So inside that closure, again we call execute, but this time we can fit it on one line quite neatly. And we substitute in the values from each row of the list. So first time through it'll do Fred, Flintstone, 42, but where it says it 0, it 1, and it 2. That's the first, second, and third elements of the sublist. Second time through Barney, Rubble, 38, and so on. So that just allows us to run 4 insert statements against the database in memory and puts it up. But normally we wouldn't have that inside the thing, but we need some data to actually play around with. To get data back out again, we just call rows. Same thing, we drop the parentheses, just pass it the select statement. If you want where clauses and subselects and all that kind of thing, you can do that, and you can use the multi-line strings and have them all nicely formatted, which is exactly what we did in our code. And you get the results back, stored in the value in the variable results in this particular case. Now the dbexecute drop table person is just so that I can run this thing over and over again without it blowing up. So you can pretty much ignore that, but it's just there for our benefits. And then we're just showing what the results actually are. So that will actually give us something in the bottom half. So if we run that, then we get what you'd expect, right? First name Fred, Flintstone 42, yada yada yada. But look at how that's formatted. That looks suspiciously like a list. It actually looks suspiciously like a list of maps. So let's have a look and see exactly what it is. Let's see. So the result, oops, no, that won't work. I double that. There we go. That's in the array list. It is just a list. It's a Groovy list. So that means we can use all the nice list API of it. That's pretty good. What about what's in the list? Let's say the first element to get the class of that. Not quite what we were expecting. That's something that's proprietary. But all is not lost, right? If we go and find out what that actually implements, it implements a map. So what it gives us back is just a list of maps, which means that we can use all of the nice API that we saw earlier to work with this stuff. So we can do things like this. We can say results.find person, no, person that way, where person.age is less than 18. And what we've done that. We've now got .age, so we're using the dot notation for the map to dereference it, and because they're just string names with no spaces in, we can actually do that. And it starts to look a bit more like you've actually got objects here, which you're completely not. You're just using object notation to actually access a map, but it starts to look a bit prettier, but you don't have to go to the full ORM. If we do that, we get Pebbles and Bam Bam back, which is good because they're the kids. Right? And just like we did before, we can chain these calls together. So we know they're children now, from child. Let's just convert this into, instead of it being a list of Groovy SQL row results, let's just change the list of strings, right? So we can say $child name, no, child first name even, is $age years old. Ooh, thank you.
We've also got 2 minutes.
Then I get to the last example, but we'll see. And then close it off. All being well, just run that, and what we've now got is a list of 2 strings. We've got completely rid of the row result stuff that we had before. We've actually got what we wanted, whatever manipulation we wanted to do on it. That makes sense? Any quick questions? We'll see if we can squeeze the last example in very, very quickly. This I didn't get to do originally, but I did know about it, so I wrote my API in a particular way. In Groovy 1.8, they introduced something called command expression syntax, and it allows you to do a lot of that dropping of the punctuation. So here we've got a little class, we've got a static method on it called say, which accepts a phrase, which is just a string, and then it returns a new say object, which has a method on it called to, which accepts a person. And then all that does is create a string with phrase, comma, space, person. Right? Then we import import the say method statically, which allows us to do this.
Well, spell it.
Can't type it. Which actually looks a lot like English. And it works. So you can actually get rid of all that stuff and start creating really cool DSLs. Now, if you are interested and inspired, then that's the book to get. That's written by Paul King, who's giving presentations today. Groovy.co.org is the website. Great conf is the conference. The mini conf we ran on Tuesday, which we're going to try and do the full conference next year with any luck. Groovy Mag is a magazine you can subscribe to that's got loads of information and articles about Groovy on it. And that's all my contact details. Thank you very much.